From space, Earth looks familiar, safe, understood. A blue marble floating in black silence, wrapped in clouds, streaked with continents, glowing with life. For centuries we have believed this world was ours, conquered by maps, satellites, and science. We draw borders across land, name every mountain, chart every desert. We have walked on the moon. We have sent machines across the surface of Mars. We have photographed distant galaxies billions of light years away. And yet, beneath the surface of our own planet lies a vast, alien world that remains largely untouched. The oceans cover more than 70% of Earth's surface. They regulate climate, produce oxygen, drive weather, and cradle life itself. But here is a staggering truth that unsettles scientists and explorers alike. We have mapped 100% of Mars, 100% of the Moon, and less than 5% of Earth's ocean floor. 5%. The rest remains hidden in darkness, crushed under miles of water, unreachable by light, unexplored by human eyes. It is a world deeper than Everest is tall, colder than Antarctica, and more hostile in outer space. A place where pressure can implode steel, where sunlight never reaches, and where life thrives in ways that defy everything we thought we knew about biology. How did this happen? Why do we know more about distant planets than the depths beneath our own waves? And what secrets are still waiting below? Humans are land creatures. We evolved to breathe air, walk upright, and survive under a narrow band of pressure and temperature. The ocean, especially the deep ocean, is profoundly hostile to us. At just 30 meters below the surface, pressure doubles. At 1,000 meters, it becomes lethal. At 4,000 meters, it can crush a submarine like a soda can. Unlike space, where vacuum dominates, the deep sea exerts relentless force from every direction. Electronics fail, materials fracture, vision disappears, sound bends in strange ways. Even the strongest metals weaken over time under constant compression. This is why fewer people have visited the deepest point in the ocean, the Mariana Trench, than have walked on the moon. Space exploration is difficult, yes, but it is predictable. Physics behaves consistently. Spacecraft in orbit, land, and transmit data for years. The ocean, by contrast, is chaotic. Salt corrodes. Currents shift. Visibility vanishes. Communication becomes unreliable. GPS does not work. Radio waves cannot penetrate water. Every descent into the deep ocean is a gamble. And yet, scientists keep going, drawn by the same question that has haunted humanity since the first sailors gazed into dark waters. What's down there? Below 200 meters, sunlight fades. Below 1,000 meters, darkness becomes absolute. This is a deep ocean, a realm without photosynthesis, where life should not exist. And yet it does. In astonishing abundance. Hydrothermal vents spew superheated water rich in minerals, creating towering chimneys on the seafloor. Around them flourish entire ecosystems fueled not by sunlight, but by chemical energy. Bacteria convert sulfur and methane into food, forming the base of food webs that include giant tube worms, ghostly crabs, and fish with transparent skin and glowing eyes. Creatures here are unlike anything on land. Some have no eyes. Others have jaws that unhinge to swallow prey larger than themselves. Many produce their own light, flashing signals in the darkness like living stars. Every deep-sea expedition discovers new species. Almost every dive rewrites textbooks. Scientists estimate that over 90% of marine species remain undiscovered. What else lives down there? What evolutionary paths have unfolded unseen for millions of years? What biological tools could inspire new medicines, materials, or technologies? The deep ocean is not just unexplored geography. It is unexplored life. When we say we've mapped only 5% of the ocean floor, what does that really mean? Most of what we know comes from satellite altimetry, which measures tiny changes in sea surface height caused by gravitational variations below. From these subtle ripples, scientists infer the shape of underwater mountains and trenches. It is clever, powerful, and incomplete. It's like trying to map a city by observing shadows on a curtain. True high-resolution mapping requires ships slowly scanning the seafloor with sonar, a process that is expensive, time-consuming, and logistically complex. Mapping the entire ocean at high resolution could take decades and billions of dollars. And while we hesitate, the seafloor remains a blank page. There may be mountain ranges taller than the Alps, canyons deeper than the Grand Canyon, volcanoes, fault lines, ancient riverbeds, and possibly shipwrecks carrying lost histories. There are even theories of submerged continents and forgotten landmasses, remnants of Earth's shifting crust, now buried beneath kilometers of water. Every blank space on the map is a question mark. The ocean does not give up its secrets easily. 5 divers have died searching Lake Toplitz. Submersibles have been lost, cables severed, missions aborted, and there are whispers, too, unexplained sonar contacts, strange acoustic signals echoing through the deep, sounds like doors slamming, like something massive moving in the dark. Some are natural phenomena, some remain unexplained. The ocean hides not only life and geology, but history, sunken cities, warships, aircraft, nuclear waste, cables carrying the world's data. It is the backbone of modern civilization and the graveyard of its conflicts. There is also fear. Fear of what we might find. Fear of what lies buried. Fear of disturbing ecosystems we barely understand. And yet, as technology advances, the silence is breaking. Autonomous underwater vehicles now roam depths once unreachable. Artificial intelligence processes sonar data. New materials withstand crushing pressure. Humanity is finally pushing back against the dark. But the question remains, are we ready for what we might discover? The irony is unavoidable. We celebrate Mars rovers, lunar bases, and dreams of interstellar travel, while ignoring the greatest unexplored frontier beneath our feet. The deep ocean is closer than space, richer than any asteroid, and more mysterious than any distant planet. It holds clues to the origin of life, keys to climate change, resources that could shape the future, and warnings written in coral skeletons and sediment layers. To explore the ocean is not just an act of curiosity, it is an act of survival. Because to understand Earth, we must understand its oceans. To protect life, we must first know where it lives. And to truly call ourselves explorers, we must stop looking only to the stars and finally turn inward toward the darkness below the waves. We know Mars, we know the moon, but our own planet still waits to be discovered, and the deepest mysteries of Earth are still drowning in silence. Thanks for watching. If you enjoyed exploring the wonders of our universe, don't forget to subscribe to the channel and share it with your friends who love the stars too. Tap the bell icon so you never miss a journey through the cosmos. Keep looking up and stay curious.